When calculating the load for track lighting according to the National Electrical Code, specifically Article 220.12b, it's crucial to understand that the 150 volt-amperes per 600 or 2 feet of track is added to the total connected load of the luminaires, meaning the individual track lights that are actually installed on the track. To clarify, the first step involves determining the actual power consumption in volt-amperes of all the lighting fixtures attached to the track. Each track light typically has a wattage rating which, for the purposes of load calculation, is treated as volt-amperes since power factor is often not known or specifically accounted for in these calculations. Total volt-amperes for all the track lights connected to the track are summed together. Next, determine the total length of the lighting track in 600 or 2-foot increments. For every 600 section of track, an additional 150 volt-amperes must be included in the load calculation. This requirement exists to account for the potential to add more lighting fixtures to the track in the future. The 150 volt-amperes per 600 provision acts as a demand factor or a safety factor, ensuring that the circuit has sufficient capacity to handle additional load if needed. The final step is to add the total connected load of the track lights to the additional load calculated based on the length of the track. The sum of these two values represents the total calculated load for the track lighting circuit. For example, consider a lighting track that is 2.4 meters or 8 feet long. This track has 6 track lights installed, each with a rating of 20 volt-amperes. The total connected load of the track lights is 6 multiplied by 20, which equals 120 volt-amperes. The track is 2.4 meters or 8 feet long, which equates to 4 600 or 2-foot sections. Therefore, the additional load is 4 multiplied by 150 volt-amperes, which equals 600 volt-amperes. The total calculated load for the track lighting circuit is 120 volt-amperes, the connected load, plus 600 volt-amperes, the additional load based on track length, which equals 720 volt-amperes. This 720 volt-amperes is the value used to determine the required circuit breaker size and wire gauge for the track lighting circuit. It is important to note that this calculation method is specific to track lighting and is intended to provide a conservative estimate of the potential load. In some cases, the actual load may be lower than the calculated load, but the code requires this method to ensure adequate capacity and safety. The NEC provides specific guidelines for electrical installations, including requirements for branch circuits and feeders. Article 210 covers branch circuits, while Articles 215 and 220 address feeders and service calculations. Understanding these articles is essential for properly sizing electrical systems. For dwelling units, the general lighting load is typically calculated at 3 volt-amperes per square foot. This value accounts for the general lighting needs of the residents. In addition to general lighting, specific appliances and equipment must be included in the load calculation. These include items such as ranges, dryers, and air conditioners. The NEC provides methods for calculating the load of these appliances, taking into account demand factors and other considerations. Demand factors allow for a reduction in the calculated load based on the assumption that not all appliances will be operating at their maximum rating simultaneously. For example, a demand factor of 75% may be applied to the total load of 4 or more fixed appliances other than ranges, air conditioning equipment, space heating equipment, and clothes dryers. The NEC also includes requirements for receptacle outlets in dwelling units. Receptacle outlets are typically calculated at 180 volt-amperes per outlet. This value accounts for the potential load that may be connected to the receptacle. In commercial buildings, the lighting load is calculated based on the type of occupancy. The NEC provides tables that specify the volt-amperes per square foot for different types of occupancies, such as office buildings, stores, and schools. These values are based on the typical lighting needs of each occupancy. In addition to general lighting, commercial buildings also have specific equipment that must be included in a load calculation. This equipment may include HVAC systems, elevators, and other large loads. The NEC provides methods for calculating the load of this equipment, taking into account demand factors and other considerations. For non-dwelling occupancies, the general lighting loads are determined from Table 220.12 in the NEC. This table provides volt-ampere per square foot values for various occupancy types. For example, an armory or drill hole is listed at 0.25 volt-amperes per square foot, while a bank is listed at 3.5 volt-amperes per square foot. A church is listed at 1 volt-ampere per square foot, and a courthouse is listed at 2 volt-amperes per square foot. A dwelling unit is listed at 3 volt-amperes per square foot. Garages, commercial, are listed at 0.5 volt-amperes per square foot, while hospitals are listed at 2 volt-amperes per square foot. Hotels and motels, including guest rooms, are listed at 2 volt-amperes per square foot. Libraries are listed at 1 volt-ampere per square foot, and manufacturing facilities are listed at 2.5 volt-amperes per square foot. Office buildings are listed at 3.5 volt-amperes per square foot, while restaurants are listed at 2 volt-amperes per square foot. Schools are listed at 1 volt-ampere per square foot, and stores are listed at 3 volt-amperes per square foot. Warehouses are listed at 0.25 volt-amperes per square foot. These values are used to calculate the general lighting load for the building. It is important to consult the NEC for the specific requirements for each type of occupancy. The NEC also includes requirements for show windows. Show windows are calculated at 200 volt-amperes per linear foot. This value is used to calculate the load for show windows in commercial buildings. The NEC also includes requirements for heavy-duty lamp holders. Heavy-duty lamp holders are calculated at 600 volt-amperes each. This value is used to calculate the load for heavy-duty lamp holders in commercial and industrial buildings. For receptacle outlets, the NEC requires a minimum load of 180 volt-amperes for each single or multiple receptacle outlet on one or more circuits. This requirement ensures that the circuit has sufficient capacity to handle the potential load connected to the receptacle. For electric ranges, the NEC provides specific rules for calculating the load. The load is based on the rating of the range and the number of ranges connected to the circuit. The NEC allows for demand factors to be applied to the range load depending on the number of ranges. For electric dryers, the NEC requires a minimum load of 5000 volt-amperes. This requirement ensures that the circuit has sufficient capacity to handle the load of the dryer. For HVAC equipment, the NEC requires the load to be calculated based on the nameplate rating of the equipment. The nameplate rating provides the volt-amperes, volts, and full load amps of the equipment. This information is used to determine the required circuit breaker size and wire gauge. When performing load calculations, it is important to consider all applicable requirements of the NEC. The NEC provides specific guidelines for calculating the load of various types of equipment and occupancies. It is essential to consult the NEC for the specific requirements for each situation. By following the requirements of the NEC, electrical systems can be designed and installed safely and reliably. Load calculations are a critical part of the electrical design process. Accurate load calculations ensure that the electrical system has sufficient capacity to handle the expected load. This helps to prevent overloads, voltage drops, and other electrical problems. In addition to the NEC requirements, it is also important to consider local codes and regulations. Local codes may have additional requirements that must be followed. It is essential to consult with the local electrical inspector to ensure that the electrical system meets all applicable requirements. When performing load calculations, it is helpful to use a load calculation worksheet. A load calculation worksheet provides a structured approach to calculating the load. The worksheet includes sections for listing the various loads, applying demand factors, and calculating the total load. Using a load calculation worksheet can help to ensure that all loads are included in a calculation and that the calculation is accurate. It is also important to keep records of all load calculations. These records can be used to verify the accuracy of the calculations and to provide documentation to the electrical inspector. Accurate load calculations are essential for ensuring the safety and reliability of electrical systems. By following the requirements of the NEC and local codes, electrical systems can be designed and installed to meet the needs of the building and its occupants. In summary, the 150 volt-amperes per 600 or 2-foot rule for track lighting in NEC Article 220.12b is an additive requirement. It is added to the actual connected load of the luminaires on the track to account for future expansion or changes in lighting configurations. This ensures the electrical system is adequately sized for potential increases in load.